Good morning. Welcome to a new video. Here we discuss sum of a generic series. There is a series term 1 plus term 2 plus term 3 and so on up to ith term plus and so on up to nth term. I need to find out sum of n terms. The generic solution is initially we assume that sum equal to 0 and then for I is equal to 1, I less than or equal to n, I is equal to I plus 1, we find out the sum adding one term at a time. Sum is equal to sum plus ith term. Okay. Now, let us apply this generic formula to 1 plus 2 plus 3 and so on up to n. Here, ith term is I. So what is the formula? Sum is equal to sum plus I. Next, 1 plus 3 plus 5 plus 7 and so on up to, I don't know what is ith term. You can guess. When I equal to 1, it is 1. When I equal to 2, it is 3. When I equal to 3, it is 5. So ith term is 2 into I minus 1. Okay. You can get any term by putting respective number in place of I. Plus and so on up to nth term. What is the nth term? It is 2 into n minus 1. Now, or simply, here I put ith term. And this is nth term. What is ith term? Ith term is 2 into I minus 1. The formula is, specific formula is sum plus ith term. What is ith term? 2 into I minus 1, where I varies from 1 to n. Okay. So this is second example. Now third example. 1 minus x square let us find out factorial n. 1 into 2 into 3 and so on up to n. Okay. So here ith term is n, ith term is I. So initially we assume that factorial 0 is 0. So if I is 0, factorial, or if n is 0, factorial 0 or factorial n, special case, equal to 0. Otherwise, you start from 1 and then for I equal to 1, I less than or equal to n, I plus plus, your factorial will be factorial into I. Okay. Now one more example. This is sine series. This is sine series. X minus x cube by factorial 3 plus x raised to 5 this is x raised to 5 by factorial 5 minus, and so on. What is the ith term? I don't know whether it is plus or minus that precedes. Ith term. Finally, nth term. I don't know what is the sign before it. Could be plus or minus. And now, ith term. What is cosine series? 1 minus x square by factorial 2 minus x raised to 4 x raised to 4 by factorial 4 and so on up to ith term. You can achieve alternate plus and minus by taking a variable initially 1. In every iteration, you change the sign. If plus, it becomes minus. If minus, becomes plus. Okay. Now, what is ith term? Sine into x to the power of this is for sine 2i minus 1 divided by factorial 2i minus 1. This is for sine. Now, what is for cosine? Sine into x to the power of 2i minus 2 divided by factorial 2i minus 2. This is for cosine series. Let us add one more thing. And this is e to the power of x. E to the power of x. 1 plus x plus x square by factorial 2 and so on. Okay, now what is the ith term? What is the ith term? X to the power of, you start from 1 here, that is x to the power of 0. So, x to the power of I minus 1 divided by factorial I minus 1. This is ith term for exponential series. Right? Let us implement one by one. In whatever language you can. Implement in whatever language you can. But I prefer Java, according to me, are universally known as one of the fastest languages because it's a compiled language, not interpreted one. Now, to create a scanner object to read the input. Actually, input can be read through command line arguments also. This is a one-time process for all the series we are going to explore. Now, let us create a variable x, which is double. The scanner class has a function called next double. So this takes care of x. Now number of terms is integer. For integer, the method is next int. Now, first one, sum of n or sum of first n natural numbers. Sum of first n natural numbers. Let us call the function as sum. It takes n. Okay, let us do it first. What is it? Or this one? 1 plus 2 plus 3 and so on up to n. Okay. Now let us go back here. Write a method inside the same class. Let it be a public method. I prefer a static method because I don't need to create an object to use this method. Let me use long because n could be a very big number. Function name is sum. Input is n. Now, create a variable sum. Start with 0. Now, for I is equal to 1 to n, I increasing in steps of 1. Update sum by I every time. Ith term is I. So return the sum. Let us put x here, which I am not using at present. Say n is 10. Execute this. Semicolon is missing. Now execute this. In scanner, this is capital. Sorry for unintentional errors. So it is 55. N into n plus 1 by 2, 10 into 11 by 2, 10 into 5.5, 55. Okay. First is done. Now second. Sum of odd numbers. Say 1 plus 3 plus 5 and so on. Sum of odd numbers. Sum of first n odd numbers. All are positive. Let us call this as odd sum. Number of terms are n. Okay. So let us write a function for that. To save time, your time, I just copy and paste it. The name of this function is odd sum. Okay. Actually, here the name of function and the variable name are same. Should be different. Let us call this as S only. Fine. Here also, let us call this as S. Now sum is equal to sum plus ith term. What is ith term? If you remember, 2 into I minus 1. Now return sum. Okay. Now fine. This is to find out sum of odd numbers. So 1 plus 3 plus 4 plus 5 and so on up to 10. 1 plus 3, 1 plus 3, 4, 9. So what are the numbers? To validate the output, let us take it 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 19, 17, 36, 51, 64, 75, 84, 91, 96, 99, and 100. So let us check. Output should be 100. Absolutely right. We are bang on target. Next. And let us find out factorial. System dot out dot print ln factorial of given integer. So let the function name is simply f for simplicity. Say f of n. Now let us write the function for factorial. Again, a public static function returns long. Function name is f. N is the input. Now we have a special case. Factorial 0 is 1. That has to be incorporated. If n equal to 0, do nothing but return 1. Otherwise, so your factorial, say FACT, is 1 in the beginning. Factorials could be very big numbers. So let us assume that it is of long data type. Now, for I equal to 1 to n, factorial is equal to factorial into I. Okay. Now return the result. Return the result. Now you got factorial n. How much it is? Static spelling is wrong. Okay. One more error. System spelling is wrong. It is 362 8800. Let us check factorial 6, which is a known number. So it is 720. Okay. So 720 into 7 into 8 into 9 into 10 is C, a very big number. How much? 36 lakhs 28,800. Next, sine series. Let us print sum of sine series. Say sine series sum. Okay. Now let us check the value of sine 1. We should get the same. We should get the same from our program without using sine function. See how much it is. Otherwise, there is something wrong in our method. This is 0.8414. We should get a value nearer to that. Okay. Let our method name is sine. X and n are inputs. Right? Now let us write a method for sum of sine series. Name is sine. Again, you need to find out ith term, which I have shown you here. What is ith term? X raised to 2i minus 1 divided by factorial 2i minus 1 and sine, which changes from negative to positive. Again, a public static method returns double. Name of function is sine. It takes two parameters, one double parameter, one number of terms parameter. Have a sign and let it be +1. Now, let sum equal to or let s equal to 0. For I is equal to 1, I less than or equal to n, I plus plus, sum is equal to sum plus sign at present positive +1 into unit power method x raised to 2i minus 1 divided by factorial 2i minus 1. Now return sum. Let us check sum equal to sum plus ith term. Before we need to do one more thing. For the next term, sign should be changed to negative. Okay. Otherwise, you don't get oscillations. Approximately the same, 0.8414. So logic is correct. Next. Let us check for cosine series. The name is, let us do it first manually. Math.pow cos 1. So what is the real value? 0.540. So we should get approximately the same. Now, instead of using library function cosine, let us use our own function cosine. Inputs are x and n, number of terms and x value. X value is, what is x value? X value is 1. Okay. You need to write cosine function. So instead of writing total method, let us make use of existing one. Copy and paste. You need to change only ith term. The name is cosine. Everything else is same. Only change the ith term. 2i minus 2. Factorial 2i minus 2. Everything else is same. Okay. So I hope you remember the value. I'm sorry, I forgot it. What was the value? Math.cos. Input is 1. So what was the value? 0.5, I believe. It is 0.50, 0.54030. So our function should give approximately the same value, 0.53. Name is cosine. Name is cosine. Inputs are x and n. One more parenthesis is required. Perfect. Now execute this. X is 1, number of terms are 10. So approximately same value. We are bang on target. Now finally, exponential series. Let us copy this print statement, or else I may end up making a mistake in spellings. Now let us check actual value. Math.exp. It will give you e to the power of 1 value, and your program should give you something similar to that. The 2.7182. Okay. Let us write our own function. And let us call this as exp. X and n are the inputs. Again, instead of writing it once again, I copy this and paste. So name is exp. Name is exp. All the terms are positive. So no need to alter the sign. This is not required. X to the power of I minus 1. Please check. Because you start from 1. 1 minus 1, 0. So x raised to 0, and then x raised to 1, x raised to 2, and so on. So this is I minus 1 is the power, and you need factorial I minus 1. Just change the ith term. Everything else remain the same. Execute this. So number of terms are 10. If you take more terms, you would come closer to actual value. Is this clear? Or the expression may be wrong. Let us Google and find out. Exponential series. This is e to the power of minus x. I want e to the power of plus x. X raised to 0 by factorial 0. Excellent. X by 1, x squared by 2, x cubed by 3, x to the power of 4 by 4. This is what we did. Let us check code once again. Ith term is x raised to I minus 1 by factorial I minus 1. Say e to the power of number of terms are 10. And this is cosine. This is exp. Okay. Let us check once again. Double. Written double. Yes. Okay. So that's it. This is all about finding sum of series using same formula, sum equal to sum plus ith term. And your IQ, your intelligence lies in finding out the ith term. Okay. So hope you understand it. In the next session, we will find out sum of prime numbers, sum of Fibonacci numbers. Thanks for watching. Keep watching. Thank you.